Okay, chapter 8.2 is about completing the square. Okay, completing the square means we will make a trinomial so that this trinomial will make a perfect square. So let's say there is two variables, x squared term and x term. X squared term and x term. So using these two variables, we can make a perfect square. So in order to make a perfect square, we need to write one more term, which is a constant term, and that constant term is always divide the coefficient of x. Divide the coefficient of x, which is b. So divide b by 2, and then square it. Then once we have these three terms, then it can be written as x plus b over 2 squared. Okay, so this is the completing the square method. So we will construct a perfect square trinomial from these two terms. Okay, so what term should be added to this binomial to make a perfect square trinomial? So what do we do? What goes to in this rectangle? Okay, so we will divide the coefficient of x, half the coefficient of x, which is negative 8. Negative 8 divided by 2. Okay, then squared will go over there. So this is equal to negative 8 over 2 is negative 4 squared. So we can write it here, negative 4 squared. Okay. So this trinomial will make a perfect square, which is x minus 4 squared. Very simple, right? So half the coefficient of x squared. So that is the third term, so that it will become a perfect square. Okay, in this case, always make sure that the coefficient of x is 1. The coefficient of x is 1. If the coefficient of x squared is not 1, like 2, then we have to factor out 2. Okay, factor out 2. So always make sure the coefficient of x squared is 1. Then we can divide the coefficient of x by 2. Then square it. So that goes to the third term. Then the binomial term is what? Is this base x and this base negative 4. So x minus 4 squared. X minus 4 squared. Okay, so the binomial, the completed square, then the binomial square is the binomial factor. The base is x plus b over 2. Okay, b over 2 is the second term in the base. Okay, how did you get the b over 2? From the coefficient. So divide the coefficient of x by 2. Okay, in this example, we will solve an equation by completing the square. Okay, in this case, we can just factor out, factor the left-hand side, but we will use completing the square method because this is very useful when we do factoring or when we find a solution of quadratic equations. So in order to make it a perfect square trinomial, what do we do? Okay, x squared plus 12x. Okay, leave some space because I'm going to put a constant term here. It's equal to 0, right? It's equal to 0. So let me put some space. And then I'm going to add what? Okay, half the coefficient of x. So 12. Divide 12 by 2. Squared will go over here. So that is equal to 6 squared. So 6 squared goes over there. So I'm going to add what? 6 squared. So in the equation, I added some number to the left side of the equation. So we got to add the same number to the right side of the equation too. Okay, because this is equation. You cannot add something to one side only. You have to add both sides. A number to the both sides. So the left side of the equation is what? It's a factorable. It's a binomial, perfect square binomial. Perfect square, right? So that is x plus 6 squared. X plus 6 squared is equal to 6 squared. Then what is this one? Then we can solve for x. So get rid of the power 2, then the base x plus 6 is equal to plus or minus square root of 6 squared. Then x is equal to negative 6. Move 6 to the right, negative 6 plus or minus 6. So that x equals what? Negative 6 plus 6. Or x equals negative 6 minus 6. Then x is equal to what? 0 or x equals negative 12. So we found the solutions. Okay, let's check if this is correct. You know, if we use completing the square method, the factoring method. Okay, just check. The factor out x, then x plus 12 is equal to 0. We set each factor to 0, then x equals 0 or x equals negative 12. Okay, this is correct, right? This is correct. So using the completing the square method will give us the same result, same solution. Okay, let's try more examples. Okay, this example is, okay, we will use the completing the square method. So in order to write a completing perfect square trinomial, we need only two terms, x squared term and x term. We don't need this 7. So let's get rid of this 7. Move the 7, the constant 7 to the right. So negative 7. Make sure to write some space on the left side of the equation. And then what do we add to each side of the equation to make a perfect square trinomial? Okay, divide this number by 2 squared. So that is equal to negative 3 squared. So this will be negative 3 squared. So we added negative 3 squared, so also we got to add the same number to the right side of the equation, negative 3 squared. Then the left side is what? The base is x minus 3 squared. X minus 3 squared. The right side is negative 7 plus 9. So x minus 3 squared is equal to 2. Then the base x minus 3 is equal to what? Plus or minus square root of 2. So that x is 3 plus or minus square root of 2. Okay, pretty simple, huh? Pretty simple. So what we have to do is we will use x squared and x term so that we can write trinomial, perfect square trinomial. So that will become a perfect square. Okay, then the third term is what? You get from the coefficient of x, negative 6. So negative 6 divided by 2 squared. Okay, that goes to the third term. And the perfect square is what? The base of x squared and this base. So x minus 3 will be the base of the perfect square. Okay, in this example, the quadratic equation does not have the leading coefficient equal to 1. So the leading coefficient not 1, then what do? We have to divide the equation by the leading coefficient. So why don't we divide each side by 2? Okay, each side by 2. Then negative 1 over 2x minus 1 is equal to 0. So let's use these two terms to write a perfect square trinomial. So first of all, we don't need this negative 1. So move negative 1 to the other side, positive 1. And then what do? We find the constants. So the constant is what? Divide 1 over 2 by 2. Divide by 2, so that is 1 over 2, right? Divide by 2 means multiply 1 over 2 squared. So that is equal to 1 over 4 squared. So we will add both sides of the equation. Negative 1 over 4 squared. So plus negative 1 over 4 squared. Okay, so this one goes over there and over there, right? Okay, then the left side is what? X minus 1 over 4. Okay, x minus 1 over 4 squared is equal to 1 plus Okay, 1 over 4 squared. Negative 1 over 4 squared is positive 1 over 16. Okay. Then x minus 1 over 4 squared is equal to 16 over 16 plus 1 over 16 is 17 over 16. So let's go move to here. So that x minus 1 over 4 squared is equal to 17 over 16. Then get rid of the power exponent 2. Then the base is equal to what? Good. Plus or minus square root of 17 over 16. Then x is equal to, okay, move negative 1/4 to the right, positive 1/4, plus or minus, separate the numerator and the denominator. So finally, x is equal to 1/4 plus or minus square root of 17 over 4. So we have two solutions. One is plus, the other one is minus. Okay, let's solve this one by completing the square. Okay, complete the square. So, okay, the leading coefficient is 1, so that we will just use these two terms so that we don't need this plus 8. So move plus 8 to the right, then there will be minus 8. And then the third term is what? Divide negative 4 by 2 squared. That is equal to negative 2 squared. So that one goes to the left hand side, negative 2 squared. Also the right hand side, negative 2 squared. Okay, so this one goes to the left, to the right. Then the left side is x minus 2 squared. This x and this minus 2. So that is equal to negative 8 plus 4. So that x minus 2 squared is equal to negative 4. You know, something squares negative 4, so the solution is what? Solution is complex number. So x minus 2 is equal to plus or minus square root of negative 4. So x equals 2. Okay, move this negative 2 to the right, plus or minus what? Square root of 4i. So finally, x equals 2 plus or minus 2i. So there are two solutions, two complex solutions. One is 2 plus 2i, and the other one is 2 minus 2i. Okay, let's do some exercise. Okay, from here, we don't need, okay, the leading coefficient is 1, so just move 32 the other side. A squared plus 12a equals negative 32. And then the third term is what? Divide 12 by 2 squared. So that is 6 squared. So 6 squared goes to both sides. 6 squared. So that the left hand side is what? A plus 6 squared equals negative 32 plus 36. Then a plus 6 squared is equal to 4. Then a plus 6 is equal to, get rid of this power 2, then the right side is plus or minus square root of 4. Then a is equal to, move 6 to the right, then negative 6 plus or minus what? 2. So this means a equals negative 6 plus 2, or a equals negative 6 minus 2. One is plus, one is minus. So a equals negative 4, or a is equal to negative 8. Okay, there are two solutions, negative 4 and negative 8. Okay, let's do the next one. Okay, this equation has the leading coefficient 5, which is not 1. So we gotta divide each side by what? 5. So x squared minus 15 over 5 is 3x plus 7 over 5. Okay, in order to use the completed square method, we need x squared term and x term. So let's move this constant to the right. Then x squared minus 3x is equal to negative 7 over 5. Okay, then let's fill up the third term, which is negative 3 over 2 squared. So negative 3 over 2 squared goes to each side. Negative 3 over 2 squared plus negative 3 over 2 squared. Then the left side of the equation is x minus 3 over 2 squared is equal to minus 7 over 5 plus, okay, negatives multiply twice, the positive, 9 squared is, 3 squared is 9, 2 squared is 4. And then x minus 3 over 2 squared is equal to, alright, the right side is what? The LCD is 20. LCD is 20. So 5 times 4 is 20. 7 times 4 is 28. Plus, the denominator is 4, so 4 times 5 is 20. 9 times 5 is 45. So x minus 3 over 2 squared is equal to, okay, negative 28 plus 45 is 17. So 17 over 20. Alright, so that x minus 3 over 2 is equal to, get rid of this exponent, then the right side is what? Plus or minus square root of 17 over 20. So that x equals what? 3 over 2. Move this one to the right. 3 over 2 plus or minus square root of 17. Separate the numerator and the denominator. So x equals 3 over 2 plus or minus square root of 17. How about the denominator? Denominator is 4 times 5. So 2 square root of 5. 2 square root of 5. Okay, 20 is 4 times 5. But in this case, since the denominator contains square root of radical, we gotta multiply both top and bottom by what? Square root of 5, square root of 5. So that we can make the denominator without radicals. So x equals 3 over 2 plus or minus square root of, okay, 17 times 5 is 85, right? 85 over, the bottom is what? 2 times 5 is 10. Okay, so this is the solution. Okay, in this exercise, let's distribute, clear the parentheses. So 2x squared plus, multiply these two, then 8 over 3x equals 5. Okay, so we will use the completing the square method, and the leading coefficient is not equal to 1. So divide each side by 2. Divide each side by 2. Then 8 over 3 times 1 over 2 is 4/3 x. And give some space equals to 5. Then what do we add each side of the equation? Okay, half the coefficient of x. Half means 1 over 2 squared. So that is equal to, okay, reduce 4 and 2, then 2 over 3. 2 over 3 squared. So we will add each side of the equation. Okay, each side of the equation is what? 2 over 3 squared. Okay, so add this number to each side of the equation. Then the left side of the equation is what? X plus 2/3 squared is equal to 5 plus 4 over 9. Then do the calculation. 5 is 1 over 5, so we can make a denominator 9, then the numerator is 45. So that is equal to, the right side is 45 plus 4 is 49 over 9. So, okay, let's move to the right. Then x plus 2 over 3 is equal to, get rid of this exponent 2. Then the right side is plus or minus square root of 49 over 9. Then x is equal to, move 2/3 to the right, then negative 2/3, plus or minus, separate the numerator, 49 and 9. So x is equal to negative 2/3 plus or minus 7 over 3. Alright, so this means x equals negative 2/3 what? Plus 7/3. Or x equals negative 2/3 minus 7 over 3. Then what is x? X equals negative 2 plus 7 is 5 over 3. Or x equals negative 9 over negative 2 minus 7 is negative 9 over 3. So x equals what? Negative 3. So we have two solutions, negative 3 and 5 over 3. Okay, this exercise, okay, 6x is on the right side. So what we do is move, okay, let's make two variable terms on one side and move the constant to the right side of the equation. So x squared minus 6x equals, okay, give some space, negative 10. And since the leading coefficient is 1, we don't have to divide anything. Then let's find the constant. Okay, the constant is what? Negative 6 divided by 2 squared. Then that is negative 3 squared. So negative 3 squared goes to each side of the equation. Negative 3 squared. So that the left side is what? X minus 3 squared. That is equal to negative 3 plus 9. Then x minus 3 squared is equal to negative 1. Okay, something squared is negative 1. This is 3. Something squared is negative 1. So the solution should be what? Complex number. So x minus 3 equals, get rid of this power, then the right side is plus or minus square root of negative 1. Square root of negative 1 is I, right? I. Plus minus I. Then x equals 3 plus or minus I. The solution is what? Complex number. Okay, let's try another one. Okay, how about 52? Okay, negative x squared minus x minus 1 is equal to 0. The leading coefficient is negative, so negative 1. So why don't we divide each side by negative 1? Then x squared plus x plus 1 is equal to 0. We just divide the equation by negative 1, so that the coefficient of x is 1. And then we need only these two terms, so we don't need plus 1. So move plus 1 to the right. And then let's find the constant. Okay, the leading coefficient of x is what? 1, right? 1. So 1 over 2 squared will go to the both sides of the equation. So the left side is x plus 1 over 2 squared is equal to negative 1 plus 1/4. Then x plus 1 over 2 squared is equal to negative 4 over 4 plus 1/4. Then x plus 1 over 2 squared is equal to negative 3 over 4. Okay, as you can see here, something squared is negative. So the solution should be what? Complex. Alright, then get rid of this power 2. Then the base x plus 1 over 2 is plus or minus square root of negative 3 over 4. Okay, so finally x equals what? Move this fraction to the right and negative 1/2 plus or minus square root of negative 3 over 4. Then x equals negative 1/2 plus or minus. Okay, the numerator is square root of 3i, right? 3i. The denominator, okay, the denominator is square root of 4. The denominator is 2. And then I will put I next to this fraction. Okay, square root of 3i, so we can separate this I, right? So there are two complex solutions.